Hello students, welcome back to our discussion on digital terrain models, satellite image and 3D. Uh, in this tutorial, I'm going to demonstrate for you how we can change a text file or ASCII file having a digital elevation of a given area into raster data model, what's called digital terrain model. Let me show you first the file, how it looks like. Therefore, this is a file. Uh, in a text format. Okay, therefore this is a text file. For example, as you can see here, these are elevation points of a given cell. Okay, given cell having a cell size of 10 means 10 meter by 10 meter area. Okay, therefore 10 meter by 10 meter area is given an average elevation of like this 75, 73, and it goes on like this. Therefore, these are very vast and large collection of numbers, but you can see here the number of columns you define, number of rows you define. Therefore, if you have files like this, it's possible to change this file into a digital terrain model and see how the area looks like. Therefore, how we are going to do that, first we need to activate the arc toolbox here. Then now, because we are going to change that text file into a digital terrain model, therefore we'll go to conversion tools. Then from conversion tools, we'll go to raster. Therefore, we are going to change ASCII to raster. Then we'll search for our file. Okay, therefore it's my file is on desktop. Okay, therefore I'll go for desktop. Therefore it's the DM file. Therefore we have this text file. Okay, as you remember, when we check that text file, therefore it has decimal numbers. Therefore in GIS, a decimal number is actually represented in terms of float number, not integer. Therefore we select float. Now we'll click on OK. Okay. Then give time for the GIS to interpolate and estimate the area. Okay, there you have it. It's completed. Now the ASCII file is converted to raster file. Then just to see how the area actually looks like, therefore we do some sort of uh, representation analysis. Then we'll go to properties. Then, for example, we can change the symbology. For example, we can stretch where we can select stretched and of course select some colors just for the representation and apply. Okay, so this is the area. This is how the area actually looks like in terms of x, y, and z values. Therefore, the basic colors that you can see here, they are actually the result of the elevation, the z value. For as you can see here, or as you can see from the left side in the table of contents, therefore the lowest points of the area are represented by this light color, and the highest or the peak points are represented by this gray color. Therefore, that actually gives you an impression that this area is actually uh, located in some sort of mountainous range. Therefore, settlement is here, might be, but the area is actually surrounded by some sort of mountain chain. Therefore, that's how we can create a digital terrain model out of a text file. And of course, we can also create, okay, if you have a contour map of an area, we can create a digital terrain model of a given specific study area of your interest uh, with a digital terrain model. Because therefore, we can change contour maps also to digital terrain model. For example, let's just take here. I have this particular contour map in my data. Therefore, we can change that contour map. For example, here, if you have a contour map like this, we can actually change this contour map into a digital terrain. Very simple and easy procedure. What we have to do is we'll go to Arc Toolbox. Okay, we need to activate that Arc Toolbox. By the way, if you just meet this Arc Toolbox in your ArcGIS or ArcMap interface, then we can just activate it from here. Then we'll go to Spatial Analysis Tool. Okay, therefore interpolation, then Topo to raster. Okay, then here we can click on the contour map, then select where to save your file. Okay, it's important for you to select where to save your file. Therefore, I just prefer to save here. Okay, for example, dm2, I can give my file. its own name. Okay, then otherwise the GIS will save all your outputs in a default geodatabase, and by the end of the day, it might be difficult for you to access your files. Therefore, as you remember from the text file that we have been observing, the cell size is actually 9.96 here. It's actually something like that, but you can just change it to 10 just to make sure it's integer. Okay, now it's working. Yeah, there you have it. Therefore, now the file is changed from topographic map to a digital terrain model. Therefore, you can untick the top contour map, then you can see the digital terrain model is represented or estimated like this one. Therefore, GIS is a very powerful tool which you can apply it for your basic interests. Okay, therefore now let's do some other exercise what's called hillshade. Hillshade is actually a very powerful tool also which actually helps you to see the area in some sort of a three-dimensional manifestation. For example, let me add one DM data. This is DM data. Okay, here. Okay, this is the digital terrain model of the area. Therefore, we can do some sort of spatial analysis. For example, first let's do some classification. It might help us just to see uh, the symbology. Let's do some sort of classification. Classify in terms of 20, and let's just select the type of color. But if you are going to create a classified digital terrain model, it's better for you to understand, or it's very, very important for you to stick to which type of color you want to see. For example, here, it's very difficult to select which type of color you are interested. In many cases, for example, in this exercise, I prefer to change the transition of the elevation from yellow to red. But it's very difficult to see which color ramp actually is from yellow to red. Therefore, what I have to do is just right click here in the drop down box of this color, represent color ramp, then I will right click and untick this graphic view. Then automatically those colors that we have been previously looking at are actually changed directly to text. Therefore, here I can look for my color, which is yellow to red. Okay, just like that. It's very easy. Then I will click on OK, then click on apply. Therefore, it's a very smooth transition of 20 classes of the area, so that whenever you prepare a three-dimensional model of a given uh, area to represent, therefore it gives you a smooth transition of the landscape. So what we have to do is we'll go to spatial analysis tool, go to surface. Okay, let's click on hillshade. Okay, then I will select DM. Okay, then I'll click on OK. Now it's doing some sort of hill shade. Okay, yeah, that's okay. Here you have a three-dimensional representation or how the area looks like if we actually do some sort of hill shade or some sort of edit. Therefore, if you just want to see the uh, digital terrain model on top of the hill shade, just let's bring it on top of that. But as you can see here, when the digital terrain model or the DM data is on top of the hillshade, it actually covers the hillshade. Therefore, what we can do is we can adjust the transparency and see both of our geographic objects that are added here at the same time. How we can do that? Therefore, we'll adjust the transparency in the display section of the digital terrain model. For example, we can adjust the transparency to 50% so that it's just like uh, oil painted paper which you can use it as a trace paper so that you can see what you are tracing on, and of course at the same time you can access your tracing paper. It's just like that. Therefore here if we do some sort of 50% transparency, therefore at the same time we can see the digital terrain model and the hill shade that we have actually prepared. Then right click on apply, then click on OK. So at the same time we have the landscape and the digital terrain model. Therefore, it's a very simple exercise just to demonstrate for you how we can prepare a digital terrain model out of a given text file. Now, the other exercise is this digital terrain model analysis is a representation of a given area in a 3D using what's called ArcScene. It's the same powerful tool that we have in ArcGIS. Okay, we can access it like here. Open ArcMaps and we open ArcScene. This ArcScene is a very powerful tool which actually shows you, or it actually is used in order to analyze an area in a three-dimensional model. For example, for this introductory exercise, I'm going to add for you satellite image of a given area that the DM is actually prepared. This is a detailed terrain model, okay? Okay, and of course, the satellite image of this area, I'll add them together on ArcScene and see how the area looks like, okay? So let's add the satellite image of the area, okay? I do have the satellite image. See, this is the satellite image of the area, okay? This is the satellite image of the area. Then I will add again the digital terrain model of the area, okay? The digital terrain model of the area altogether, okay? The digital terrain model and the satellite image is actually added here. Now, my objective here is I want to add, okay? The satellite image only have these X and Y values. Then my interest here is to add Z value so that this image or this satellite image will have a landscape representation with the values of Z, which are actually extracted from the digital terrain model. Therefore, how we can do that, just right click on the satellite image, we'll go to properties, then we'll add, okay, or we'll go to base height and we'll select what's called floating. Therefore, this floating is actually a floating numbers of the elevation data that we have been looking at in previous uh, earlier in this session will have impact on the outcome of this satellite image. And of course, it actually gives you how the area looks like. Okay, therefore, automatically the GIS will take, okay, those float numbers from the DM that is actually added here. Therefore, otherwise, if you have a lot of digital terrain models or a lot of files here, make sure that the digital terrain model which you are interested to extract Z values actually selected here. But because we have only one before, automatically it will capture by default the available digital terrain model. Therefore, that's okay. Then in many cases, the base 8 custom value, it actually ranges from 1 to 1.5. Therefore, in this case, let's add 1.5 and see how it looks like. Go to apply. Then click on OK. So see how it actually is very interesting. Therefore, it's very interesting for you, okay? See how the area looks like. It's very interesting. Therefore, previously it's a two-dimensional model of the area, but now we added the Z value, which is actually extracted out of the elevation data here, digital terrain model. Therefore, automatically for you as an engineer, you can have the very first impression of the area without just physically being there and see how you can provide this community with this type of settlement. And of course, for you to select different sites for different uh, infrastructure develop. For example, such elevation profile analysis might be interesting for you, for example, in order to select reservoir sites, okay, in order to select, for example, a lot of storage tanks and so on and so forth. Therefore, yeah, you can use this output data in order to decide a lot of aspects with respect to community settlement. Therefore, I hope you will find this video interesting and I encourage you to practice this procedure on whatever data that you have or if you have interest in doing this exercise, just let me know via your email so that I can attach the file for you so you can use it for your practical purpose. So I thank you so much. So I will see you by next tutorial on which we'll try to do what's called georeferencing. Okay, georeferencing and of course preparation of other digital terrain models. Okay, out of open sources. Yeah, let me know if you are interested in these tutorials. Thank you so much. Just enjoy your stay. Okay.